All right, welcome back. This is the final section of chapter 3, and this is really where we start getting into the core of parallel and perpendicular lines. If you go ahead and look at the text on this section, I'm leaving some parts out on this video, and that's because I don't cover them in class. That's directed line segments and uh, dividing a segment into a ratio. And from my experience, I just never really use that past this level. So I'm going to jump right away in talking about the slopes of parallel and perpendicular lines by stating a couple of theorems. So we're going to start with theorem 3.13, which is going to be the slopes of parallel lines. And it might be a good reminder to talk about the slope in general is going to be your rise over your run. Remember, that's y2 minus y1 divided by x2 minus x1. And what we know about the slopes of parallel lines is the following. Say this is our coordinate plane right here, and we skewed it on this x-axis. And I'm going to draw this yellow line here. I'm going to draw this blue line right next to it. Here we go. So say now that we know that these two lines are parallel. So this blue line is parallel to the yellow line. Then we can conclude the following. Parallel lines have the same slope. If we were to calculate how far this drops versus how far it goes to the right, and how far this drops versus how far it goes to the right, that would be the same number. Theorem 3.14 then is going to be the slope of perpendicular lines. And this is almost just as straightforward as parallel lines. It's just a little bit different when you look at it for the first time. So here is our coordinate plane skewed on the x-axis again. And our yellow line is going to be running this way. And our blue line needs to be perpendicular to that. So it's going to be running in the opposite direction. So if it's running in the opposite direction, you already know that one slope must be positive because it is heading up, and one slope must be negative because it is heading down. And in fact, it is heading down as a reciprocal of the other. And so perpendicular lines have opposite reciprocal slopes. And so what that means is that this line has a slope of m is equal to, say, x over y. Actually, let's do y over x because that is rise over run. Then this slope down here for the blue line is going to be m is equal to the opposite being a negative. So if it's negative, make it positive. If it's positive, make it negative. And then we're going to do the reciprocal. So what's on top, what's on bottom, get flip-flopped. The top line, the yellow line, has a slope of y over x, and the bottom one has a slope of negative x over y. So if I were to draw now a coordinate plane with a bunch of lines going through it, and this might take me a second, I should have definitely pre-drawn this one, but that's okay. Okay, so I just went and found the image and pasted it here. But here is our image, and we have all of these different points going on. We have, or different lines going on. Right here we have line A, that's that blue line. We have line B, that's that red line. Line C, which is that, I don't know, weird blue-green line. And then finally we have line D, which is our purple line going through everything. And I want to find if any of these lines are parallel or perpendicular to one another. Now visually, it looks like A, B, and C could all be parallel to one another, and it looks like line D might be perpendicular to all three of these lines. But we don't know that unless we look at the slope of each line. So our step is going to be find the slope of each line. And so we can do that by finding the slope of each line. So let's start with A. We're going to do that in blue. Remember that slope is rise over run. So I'll just write that up here. y2 minus y1 over x2 minus x1. So our m is going to be, it doesn't matter what you pick for y2. We're going to do the point that's further on the right. So we're going to do 3 minus the point on the left, 2. And then we're going to do our x coordinates of 0 minus a negative 3. So 3 minus 2 is a 1. 0 minus a negative 3 is a positive 3. So line A has a slope of 1/3. Let's go ahead and do B now. M is going to be equal to y2 is going to be 0 minus y1, which is a negative 1. And then x2 will be 2 minus an x1, which will be 0. So we got a negative 1, 0 minus a negative 1 on top, so positive 1, 2 minus 0 on the bottom, that is a 2. So line A and B, not parallel. Next, let's look at line C. So we're going to take m is equal to, x2 is going to be a negative 4 minus a negative 5, and we're going to take a 1 minus a negative 1. Negative 4 minus a negative 5 is a positive 1. 1 minus a negative 1 is a positive 2. So what do you know? These two lines are parallel to one another because they have the same slope. So line B is parallel to line C. Finally, let's take a look at the purple line, line D, and notice here that one of our points is actually going through line A, so we can use that as our x1, y1, and x2, y2 will be negative 2, 0. So we're going to take 0 minus negative, or sorry, 0 minus positive 2, and we're going to take a negative 2 minus a negative 3. So that's going to be a 2 over a 1 or a 2. Oops, sorry, 2 over a negative 1. No. This is going to be a negative 2 over a positive 1, so that's going to be a negative 2. Look at now that this one and this one are opposite reciprocals of one another. And so we know that line D must be perpendicular to both B and C, because 1/2 and negative 2 are opposite reciprocals of one another. So what this has all been accumulating to is finding equations of a line that are parallel to another line. So why don't we do an example of that? We want to find a line, the equation of a line, parallel to y is equal to 2x minus 3, passing through the point negative 1, positive 1. So let's identify all the information that we need. First, we need to find the slope of our new line. And we know that we want these lines to be parallel, so it has to have the same slope as this equation right here. And that slope is right here, because this is y is equal to mx plus b. And m is our slope, so m is equal to 2. And we know that parallel lines have the same slope. So m is equal to 2. Next, we need to plug this into point slope form. And so our point is going to be negative 1, positive 1. And point slope form is y minus y1 is equal to mx minus x1. This y without a number right here and this x without a number right there, those are going to remain y and x. We just plug our point, negative 1, 1, into y1 and x1. So we're going to take y minus y1, which is a 1, is equal to m, which is 2, x minus x1, which is a negative 1. Now let's solve this so this looks like an equation of a line. So that's going to be y minus 1 is equal to 2x. Negative 1 minus 1 is a positive 1, multiplied by 2 is a positive 2, and then we're going to add 1 across to solve for y. So y is equal to 2x plus 3. Let's go ahead and do a very similar thing now for a perpendicular line. So we're going to find a perpendicular line to the equation 2x plus y is equal to 2. And we want to pass through the point 2, 3. And so our first thing we need to do is find the slope. And so we have this equation right here. Let's go ahead and convert this equation to slope-intercept form. So if we take 2x plus y is equal to 2, and we solve for y, we're going to take y is equal to a negative 2x plus 2. And so our slope is right here. So our old slope, m, is equal to a negative 2. We know that perpendicular lines have slopes that are opposite reciprocals. So we're going to convert this to the opposite, which is a positive 2. Oops, let me write m first. Which is a positive 2, and a reciprocal, we're going to put it underneath 1. Next, we're going to plug into point float form. So y minus y1 is equal to mx minus x1. Our m is going to be right here, and our point x1, y1 is right there. So we're going to take y minus 3 is equal to 1/2 x minus 2. And so we're going to have y minus 3 is equal to 1/2 x minus 1. We're going to add 3 to both sides to get y is equal to 1/2 x plus 4. So that's how you'll find a line that would be parallel or perpendicular to a given line going through a specific point. If you have any questions, please let me know.